Hi everyone and welcome to Smart Alex Coaching. We offer mathematics tutoring for primary and high school students, both online and face-to-face. In this video, we're going to be introducing the radian measure and look at how to convert between degrees and radians. When we introduce the unit radian, students often ask, why do we need radians when degrees are already an effective unit for measuring angles? The students are not wrong, so let's start off by comparing these two units. The degree unit measures the amount of rotation, and we define one revolution as equal to 360 degrees. What that means is if you've got a circle and you walk around this circle once, you would have rotated 360 degrees. But why the number 360? This is really quite arbitrary because you can choose numbers such as 100 or 1000. Well, some say that this may have come about as it was previously thought that the Earth takes 360 days to go around the Sun, and one day would be equivalent to 1 degree. But apart from that, the number 360 has some advantages. Firstly, 360 has many integer factors, and this makes it very easy to do mental calculation. We can easily work out what a quarter of 360 is, that's 90. We can work out 1/3 of 360, which is 120, and so on. But the disadvantage of the degree measure is that there is no connection between the rotation and the physical circle itself. For example, it is not connected to how big the circle is, the radius, nor the arc length, and it's therefore not ideal for calculus. On the other hand, the radian measure connects the rotation and the circle. Radian is defined as the ratio of arc length L to the radius R. Theta is equal to L on R. So what does 1 radian look like? 1 radian is equal to the angle subtended at the center by an arc whose length is equal to the radius of the circle, and this equates to approximately 57 degrees. To illustrate this, suppose I have this circle whose radius is r, and I trace along the circumference for a distance L, which is equal to r, then the angle subtended at the center here is going to be equivalent to 1 radian. How about 2 radians? 2 radians would mean that starting from this point, I go around the circle for total distance. This time L is equal to 2r, so that's this arc length here. And this time the angle subtended at the center is going to be equivalent to 2 radians. So extending this idea further, what is 1 revolution in radians? Theta is equal to L on R, but a full revolution would correspond to the entire circumference of the circle, which is 2 pi r over r. The r's cancel, which results in 2 pi. So 1 revolution is going to be equal to 2 pi radians, which we know is equal to 360 degrees. I divide both sides by 2. I'm going to get pi radian is equal to 180 degrees. And that's the connection between the radian unit and the degree unit. Pi radians is equal to 180 degrees. The advantage of the radian measure, as mentioned, is that it connects the angle of rotation with elements of the circle, in this case, the radius and the arc length, and this makes calculus involving trigonometric functions a lot simpler. The disadvantage? Well, it's not a common unit in daily general use, and the irrational number pi is a lot harder to work with than whole numbers. Let's look at some examples on how we can convert from degree to radian conversion. In example 1, I want to convert 60 degrees to radians. The method I like to use is equivalent ratios. So what I know is the ratio between radian to degree is such that pi radian corresponds to 180 degrees. Now 60 degrees is what I want to convert, and let r be the variable corresponding to the number of radians. So I've got r to 160. And these two ratios must be the same. Now we're going to use the fact that a to b is the same as a over b in fraction form. So I can write pi over 180 is equal to r over 60. To solve for r, I multiply both sides by 60. The 60 here will cancel out. And what I'm going to have is r is equal to pi over 180 times 60, which correspond to pi over 3. That means 60 degree is equivalent to pi on 3 radians. What we notice here is that to convert from degrees to radians, there is a factor that we can multiply by. And this factor is pi on 180. So to convert from a degree unit to a radian unit, all you have to do is multiply that degree number by pi over 180. In example 2, I'm now going to convert from radian to degree, starting off with the same ratio. So the radian to degree, we know that's pi to 180. We're given it's 5.2 radian, and let d be the degree value I'm looking for. Setting up the equation, pi over 180 has to be the same as 5.2 over d. I'm now going to take the reciprocal of both sides. So I'm going to have 180 over pi is equal to d over 5.2. What I'm going to do now is multiply both sides by 5.2. And this means that d is going to be 180 over pi times 5.2, which is approximately 298 degree to the nearest degree. Here, to convert from radian to degree, what we do is we multiply by a factor. And again, this factor is 180 over pi. Now, you can use this method, but for me, I find that it can easily get confused between whether I'm multiplying by pi over 180 or 180 over pi. So I like to start off from first principle, just using the equivalent ratio. In our last example here, I want to convert pi over 5 radians to degrees. This time, I'm not going to use the equivalent ratio method, but I'm going to use the fact that pi radians correspond to 180 degrees. And what that means is pi over 5 radian is simply the same as 180 degrees over 5, and this is just going to give me 36 degrees. So therefore, pi over 5 radian is equal to 36 degrees. Thank you for watching this video, and I hope that you enjoy it. If you do, please consider subscribing and share it. We'll be producing more maths videos, and I'll see you next time.